Ar-Rahim. I'm going here to show you how to use the classes and methods, which is the classes mainly here. Java and the JDK comes as simple, like what you see here. So I created a simple program. Let me just test it with the print system. Dot out dot print len. Welcome. Let's just test it. Then I'm going to save that into I call it classes demo. Then compile and then we do the run. Okay, this is compilation completed. Run. We have this will come up here. So that's fine. Now we have a few classes. We can use them ready to get more functionality. You go to Google, and in Google type Java documentation. Here it is. I think the second one, this one, overview of Java, you will see here many classes exist here. All the classes comes with the JDK. These are ready with JDK, all of these. So to keep the JDK simple and not heavy, they made it just ready to do the simple programming. But if you need to use more functions, then you can use any of these classes. The classes are, it could be some of them comes implicitly within the language, like system comes with the language. When you say system dot something, we're using the system class. So some of them maybe, let me see if we have okay, let us go to the simple ones I want to show you here, which is the math. So if we go alphabetically here to MLM, so this is the math. If you click on the math here, you will find some explanation to the math class. There are fields here, something fixed, you can call them by calling, say, math dot. This is the E, which is for exponential and for logarithmic, natural logarithm, and the pi, which you know. The pi is the value of pi. If you click here, give you more information about it. What's the pi? How to use it? How to, whatever. So this is the definition of it. It is public static final double pi. So the pi is already set for you, which is 4 point something, 3.14, something like that. We'll see it in a minute. So how can we call it? Let me go back and call it. So if I go here, and I'm going to print, instead of this, I'm going to print the math, which is the name of the class, math dot pi, all capital here. Let us see what is going to return to me. When I run it, it comes to me. See, this is the value of pi, 3.141, blah, blah, blah. So you don't need to remember, you don't need to mention, just use it with the math which exists there. See, so this is what we have it. The pi is already set to you, but where it is within the math. So if you say just pi, it makes no sense, because you are calling a variable which is not exists. So if you compile, you will get error. Compile here, definitely you will get error, because what's pi? Where pi comes from? You didn't mention or you didn't define in the program, then it will be definitely of something which is mistake. So it is still compiling. Let us wait. You see here, so we got something like cannot find symbol pi. Cannot find it. Yes. Where is the pi? Not defined. But when you say math, you cannot say small m. It must be math. M-A-T-H dot. That means the field which is exist here, the field of the math. And this is the math. So this is the there are fields. This is the field of pi, which is for the math. These are just fields. It comes with math, capital M. Return double. The value of pi is double. And as well as the fields, there are methods which do some action, like absolute value of something. You put a value like minus whatever, it will be the absolute value, remove the minus. And there are many of the absolutes. Sine, cosine, all these exist there. See, this is cosine, which means takes a value here of type double and return double to you. So if you say cosine of 45, it will give you, its angle, give you the double, which is the value of it. Exponential. So the important things you need to know, you don't need to know all of them, but one nice here, it's max. So it takes float A, float B. It will return what to you? It will return to you float. Which float is the max of these two values? So how to use it? Use it like, you don't put the float and the float B. So you put A and B, it must be of type float. So if we go to where it is here, one of the methods which is the math here, as you have the max. See, there are many things here. I'm going to see the max sticks. There are several max. You see why? Because if you want to use float and float, it work. If you want to use double and double, it work. But there is no max. Yeah, there is integer and integer. You can use integer as well. So anything, that means, you see, they put it with different types. Then any type you put, it will work with you here. But it will return to you, if it is integer, return to you integer. If it is float, return float. If it is double, return double. Okay, so let us see how can we apply this. I'm going to write another one, system dot out dot print. And then if I put max, it will not work. So I have to put math dot max. And I put whatever. Integer, 20, 25. What will return to me? Return to me should be 25. So if I compile, it's completed, run. You see, it returned to me the 25 here. If I put whatever here, if I put 30, for instance, and run it, let's say, let's compile it automatically, I suppose, out of sync. Yeah, because that in Dr. Java you have to compile it and then run it. Okay. See, the 30 returned back to me. If I put minimum, it should return to me the minimum. The minimum is what? 25. Should be the 25 return to 25. Okay, so this is to show you, and it could be like this. You have int a equal, or whatever, number one equal to 50, and int number 2 equal to 40, and then int result. You don't need to put any value here, and you can calculate result equal to math dot max or minimum, maximum, minimum, max of number 1 and number 2. Then you print here, print result. So whenever there is a return, the return must be captured in something, either in a result in this case, or directly when I put them like these math dot max directly in the print, then the return value of that, it will be printed automatically directly. So that's possible in both cases, because the definition saying it return value. See, this is the 50. Because it say what? How to read it? We read like this. This is belong to math. So the math is here. So you have to put math dot. See, the math comes from where? From Java lang. If it is lang, that means it comes with a JDK. So you don't need to say import. Not like util, because this comes with a lang, a real language coming. Okay, so math here, and any of these you can use math dot any of these. But if it is one argument here, like here, you put 1. But if it is 2, you put 2. If it is 3, you put 3. And what's the type of it? Not, this is the definition of it. But you put value, or you put a declared as integer, also the float work, but return float. This is the return. When you see return, it must be either captured in a variable of that type, then whatever you want to do with it, use it or print it or whatever. Or if it is just a print, you can put that directly to see the print. What else here? There are many things here, signs. Let us try this square root. Square root takes double value of a, of anything, and double. Just focus on the double. And return what? Return double. Then let us try it here. So I can say here, I don't want to print these, but I'm going to print the square root. Math, capital M, dot square root of, here takes one variable. If I put 25, that 25 will be converted into double, because the integer is smaller than double. It's fine. Or you can put 25.0. Then whatever going to return, either it is captured in result, which you can say result equal to math square root, and then print the result, or you put it directly here. So now compile and run. Then comes to me here 5, which is the square root. Even if I put 20, square root of 20 is, you see, 4.4.7, because this is double here. The last example I want to show you, there is one called POW, maybe useful to you in something. PQR method summary. M. This is random. Return to your random value. If you have dice or something you want to play, then you can use that one. PQR. This is the POW. You see POW? POW, POW, takes 2 parameters, double, and return double to me. So if I have the, let me put it here. Okay, so let me have here POW, and here 2 values. So this is too high, so I'm going to make it smaller. And then 2 raised to power 3, and 2 us 3. This means, so if I print here result, should return to me 2 times 2 times 2. Which is what? 2 times 2, 4 times 2, 8. Compile. And mistake here, why? POW of what's it saying. Let me read what's saying. Possible logic conversion from كذا double to integer, because these are integers and it will return double. Yeah, this should be double because the expectation of the printout is double. As you see here, it's a return double, so it must be doubled here. If I compiled, run, see, 8. That's the power of 4 to power 5, and 4 times 4 times 4 times 4, 5 times. If I compile and run, it will come like what? 1024. Okay, so this is about the math. There are several other things which is not only the math. I'm going to show you in the next video. I'm going to stop now.